Children, you are asking about balancing of chemical equation. Here, before going to that, first of all, let us see what is an equation is. In equation, we are going to write the symbols and formulae of the reactants and products. What are the chemical compounds which are involving in the chemical change, which are known as reactants, and the compounds which are there formed after the chemical reaction, which are called as products. That we are going to show with the help of the symbols and also formulae. Symbols and also formulae, that is known as chemical equation. So in this chemical equation, these reactants and products whatever are formed, these have to be balanced. First of all, let us answer this question. Why we have to balance? Because here you know that atoms whatever are there participating in the reactions, these are neither created and they are not destroyed also. They are not destroyed also. But what is happening? Only chemical bonds are breaking and making. Making and breaking of the chemical bonds you can observe here in these chemical equations. But atoms are neither created nor destroyed. This is the reason we are balancing the chemical equation. Then how to balance it? How to balance it? Write only coefficient. Write only coefficient before the formula or before the symbol. But don't change the formula, don't change the symbol of the element. Now for example, I have here hydrogen reacting with oxygen to form water. This is an unbalanced equation. Without balancing, if you have the equation, that is called as unbalanced, or we have another name also here called as skeletal equation. Skeletal equation. It is like skeleton of our body. Without the muscles, without the bones and all, we call that, only bones are there, without blood, muscles, all these things are not there, we call it as a skeleton, no? Same like that, without balancing, if any chemical equation is there, that we are calling it as a skeletal equation. So here you can see hydrogen and oxygen reacting to form water. Here you just observe children, we have written 2 for hydrogen. Why we are writing? Because it is a diatomic molecule. It is a diatomic molecule. Even oxygen also diatomic molecule. That's why we have to write 2. H2O. We have written here because the formula of water is H2O. According to our symbols of ions, we have seen already water formula is H2O. So hydrogen reacting with oxygen to form water. But in this equation you see children, 2 oxygen atoms are there on the reactant side, but product side we have only 1. 2 oxygen atoms will not react together to form 1 oxygen atom, no. That only we have seen here. Atoms are not destroyed. New atoms are not created, and already which are there, they are not destroyed. So what we have to do here for balancing, we have to write 2 before H2O. Then, now you see this, hydrogens, not balanced. So what you do? 2 you write before H2. But don't change this part. This part you can't change. Before that formula or before the symbol only you have to write the coefficient. Some number you write so that it gets balanced. Okay. One more example we'll see. Observe this equation. Nitrogen is reacting with hydrogen to form ammonia. In this one, left hand side you see 2 hydrogens, 2 nitrogens. But here 1 nitrogen, 3 hydrogens. So first of all what you do, better you balance nitrogen. Better you balance nitrogen because here 2, here only 1. So easily by writing 2 before ammonia, you can balance it. You can't write N2H3 here children. Be careful, don't change this part. This NH3 we are not going to change. In the starting level, better you put a bracket or put a box surrounding the formula. That part should not be changed. Then what we have to do here, 2 we have written before NH3, nitrogens balanced. Then what about hydrogens? Here 2, here 3. Here 3, but here 2 also is there, no? So 2 into 3 we can do. 2 into 3, 6. Here to make this 2 into 6, what we can do? 3 you write before hydrogen. N2 plus 3H2 gives rise to 2NH3, that is the balanced equation. Now let me take another equation children. I am taking here calcium carbonate decomposes into calcium oxide and carbon dioxide. Here in this equation if you observe, calcium 1 atom on left hand side, 1 atom right hand side, balanced. Carbon 1, here also 1, balanced. Oxygens 3, here also 1 plus 2, 3. Already it is balanced. So no need to do anything here. Don't put unnecessarily 2, 2, 2 everywhere. Simple ratio should be there. Okay, already balanced, so that's why we are not touching this one. Now let me take water decomposes into hydrogen and oxygen. What to do here? Here also oxygen is there, left hand side only one. Here two are there. So write 2 before H2O. We are not going to change this formula. You remember this. Before the formula, before the symbol only, you have to write the number. Okay. So 2 you write before H2, 2 you write before H2O. Now it is balanced. First we have balanced oxygens by writing 2 before H2O. After that we have written 2 for balancing hydrogens. We have written 2 before H2. Okay. Next, after this, let me take here iron reacts with copper sulfate to form iron sulfate and copper. Now just observe, how many iron atoms? Left hand side, right hand side, only one. Copper, left hand side, right hand side, only one. Sulfur, only one. Oxygens, 4. Both the sides the same number is there. So already balanced, no need to do anything. Okay. So like this, you have to see that left hand side, that is reactant side, right hand side, that is product side. Same number of atoms should be there. Same number of atoms should be there, because we know already that atoms are not created, not destroyed. Iron, iron, copper, copper, sulfur, sulfur, oxygens, oxygens. Same number is there. Now let me take another one, children. Here I am taking one chemical equation, that is calcium hydroxide reacting with hydrochloric acid to form calcium chloride and water. Now, how to balance this equation? Just observe here, calcium atoms we have only one, but oxygens how many are there? Here 2, here hydrogens also 2, and here hydrogens how many? Only 1. 1 plus 2, 3, but here only 2. Chlorines only 1. So better to balance chlorines first. 2 are there here, chlorines. 2 you write before HCl. Now you check hydrogens how many are there? 2 plus 2. Here only 2. Better to write 2 before H2O. You can't write H4O. You know already water formula is H2O only. You are not going to change this part again and again. I am saying because many of the students are doing the mistakes. Don't change the formula. Don't change the symbol. But you write only coefficient before the formula. Then you check it now. Chlorines balanced. Hydrogens balanced. Then what about oxygen? 2 oxygens. Here also 2 oxygens. Calcium how many? 1. If you are confusing, then what you do, children? Just write this table in rough. You can write this table. You just write like LHS. LHS means left hand side. RHS, right hand side. You write down here how many atoms are there, which type of atoms are there. Here calcium is there, oxygen is there, hydrogen, chlorine. How many are there left hand side after balancing? After balancing 1, right hand side 1. Oxygens how many? 2. Here also 2. So 2, 2. Hydrogens how many? 2 plus 2, 4. Here also how many? 4. Chlorines how many left hand side? 2. Here how many? 2. By writing this table like this, you will get a clarity that already this equation is balanced. Before balancing also you can write to check whether they are balanced or not. After balancing also you can write this table and you can check it is balanced. Okay, children? So try some more also which I have given for you.